Mr.A Sathish Kumar. So, from Institute of Aeronautical Engineering College, Electrical and Electronics Engineering Department. Now, I am going to teach the polyphase induction machines. That is, introduction to the induction machines. Okay. So, the topic is the introduction to the induction machines. Okay, what is the induction machine? The induction machine is nothing but is similar to the DC motor and DC generators. That is similar to the DC machine only. So in case of the induction machines, we have the induction generators and the induction motors. The induction generator is nothing but it converts the mechanical energy to the electrical energy. Similarly, induction motor converts the electrical energy to the mechanical energy. That is similar to the DC machine operations. And coming to the principle of induction machines is same as the transformer. Okay, means the induction machine is basically a rotating machine. Okay, but in case of the DC machine also is rotating machine. But in case of the induction machine is the rotating machine. The principle is same as the transformer. And coming to construction, for in case of the induction generator as well as the induction motor, the construction is same. But the principle is depends on the mutual induction. Okay, so mutual induction. According to the mutual induction, the conversion of the energy from the electrical to mechanical or the mechanical to electrical depends on the induction generator or induction motor. The working will be done in case of the induction machines. Okay, and the induction machine is the rotating machines. So means in case of the induction machines, we have the stator and the rotor parts will be there. Okay, then we will discuss in the stator and rotor parts in case of the construction of the DC machine. Okay, and construction wise, there is no difference between the induction generator as well as the induction motor. The construction is same and the principle will be same as the transformer principle. That is transformer principle. That is the mutual induction. Okay, so now. So means here now introduction. Here the induction machine is basically a rotating machine. Okay, and it is either to convert the mechanical energy to electrical energy. That is in case of the induction generator, or to convert the electrical energy to the mechanical energy. That is in induction motor. Okay, and the induction machine is similar to transformer as we discussed in the earlier only. Is similar to the transformer. That is a single excited machine like as a transformer. And the induction machines is similar to the transformer principle, that is the mutual induction. In case of the induction machine, the secondary will be rotated, that is the short circuited here. And the rotating magnetic field, when we are going for the induction machines, that will be depends on the rotating magnetic field. So means what is in the rotating magnetic field? So means when the balanced polyphase currents, flow in balanced polyphase winding on RMF will be produced here. Means rotating magnetic field will be produced here. Okay, and in other words, in case of the polyphase machines, that is nothing but in case of the AC machines are associated with the rotating magnetic fields. Okay, and in their gaps. In case of the induction machines also will be depends on the rotating magnetic field only. So depends on the rotating magnetic field in case of the stator winding or in case of the rotor winding, the mutual induction process will be going on. Okay. Now I will discuss about the construction of the induction machine. So this is the construction. So coming to construction, here we have the stator parts as well as the rotor. So coming to stator parts, the stator of an induction motor consisting of the stator frame and the stator core and the types of slots and the polyphase distributed winding and the two end covers and the bearings. These are the construction part of the stator. Okay, so now what is in the stator frame? Now I will discuss about the stator frame. So this is the construction. You can observe in this here. So this is the stator. Okay, and this is the leads, and this is the frame of the stator frame, and this is the fan cover. So this is the practical induction machine construction. This is the practical diagram when we are using the practical case. So this type of machine construction will be there here. Okay, so this is the upper part in nothing but what stator here, and the stator having the stator frame will be there, and these are the lead terminals, and this is the fan cover. Okay, and this is the rotor. Okay, and this is the base, and this is the rear end hill, and this is the fan for the cooling purpose. Okay, and this is the terminal box. This will be placed to this lead for the protection purpose. Okay, and this is the bearings. Okay, this is the front end bell, and this is the oil seal. So this is a practical induction machine. Okay, now so stator frame. First is the stator frame. The stator frame of electrical machines are structures in with stator core will be assembled. This is the stator frame. Okay, so in this stator frame of electrical machines are structures in which stator core is assembled. And the stator frame is severe for distinctive purposes. That is, they enclose the core windings. The stator frame will be encloses the core winding, and they shield to the live and moving machine parts from human contact. And also, they serve the ventilating housing or means of guiding the coolant into the effective channels. And also, it provides the mechanical support to the stator core and are not designed to carry the stator flux. Okay, and this is the made with the cast iron. The stator frame is made with the cast iron. So this is the stator frame. The next is stator core. This is the stator core diagram. So it is the stationary part. This is the stator core is the stationary part. Okay, and this is the build-up of high grade alloy steel, that is the silicon steel. So we are not using the CRGO steel here in case of the stator frame construction or rotor frame construction in case of the induction machine, because of the low reluctance will be there in case of the CRGO steel. That's why we are using here the silicon steel laminations only we are using to reduce the reluctance path in case of the rotor as well as in case of the stator. Means here the stator core is built up of high grade alloy steel, that is the silicon steel laminations will be used. And also it provides the space for housing the three-phase stator windings, and also from the path for the rotating magnetic field. It will be produces the some path for the rotating magnetic field, and this is in the large number of insulated will be there for the thin laminations. So why I am using the thin laminations here is nothing but to reduce the reluctance path or to reduce the losses in case of the AC machines or in case of the induction machines. We are using the thin laminations. Okay, that will be approximately 0.35 mm to 0.65 mm thickness will be there, are stuck together here. Okay, and this is the insulated stator conductors are placed in this there. So you can observe this is the diagram. In this diagram, this is the steel laminations I am using. This steel lamination thickness is approximately 0.35 mm to 0.65 mm thickness will be there. These are laminations are stacked together here. Okay. Next is this is the types of slots. In case of the stator, this is we have the different types of the slots will be there. That is the shape of the slots has an important effect upon the operating performance of the motor. This type of slots only will be depends on the operating performance of the motor will be depends on the slots only. So generally we have the three types of the slots will be there for used for the induction machines. That is the open slots, another is the semi-closed slots, another is the closed slots. These three types are used for the operating performance of the induction machine. So next, open slots. Here this is the open slots. You can observe this diagram. So this is the open slots. And this is the open slots. Okay, this is the open type slot. You can observe here. The secondary is the open here. And this is the some advantage will be there in case of the open slots, that is the easy access of the winding without any problem. And also winding procedure becomes very easy, and the less leakage reactants and the leakage flux will be there in case of the open slots. Okay, these are the advantages for the open slots, but we have the so many disadvantages there in case of the open slot. Because of wide opening slots, average air gap length is more, so reluctance is more in case of the open slots. So because in case of the open slots, the leakage flux or the useful magnetic flux, okay, the leakage flux will be linked with the stator or rotor frame. Okay, so means, but not in both cases. That will be linked with the stator or either way the rotor. Not in case of the both, in case of the leakage flux. Okay, so means here the leakage flux will be affects the inductive reactance. The leakage flux will be affects the inductive reactance. Okay, of the that due to this effect of the inductive reactance, then the performance of the induction motor will be decreased. Okay, that is the disadvantage in case of the open slots. And the useful flux, whatever the useful flux will be there, useful flux will be produced in case of the stator. That useful flux will be linked with the both stator as well as the rotor. Okay, but the reactance flux will be that is linked with the either stator either rotor, but not for the both. But the useful flux will be linked with the stator as well as the rotor. Okay, that is the disadvantage in case of the open slots. Okay, and also it will be requires more excitation current and the poor power factor we need. And the air gap flux distribution is not uniform, and due to non-uniform flux, the distribution harmonic torques are produced in case of the open slots. So means these harmonic torques will be causes lot of vibrations and the noise in case of the induction machines. So means due to this harmonics, then I am getting the lot of noise and the lot of vibrations will be there for in case of the induction machines. So this is the case of the open slots. Next is semi-closed slots. Okay, so in case of the this is the semi-closed slots. You can observe here. This is the in case of the open slots. This will be there. Okay, semi-closed is nothing but some of the portion will be closed here. Okay, some of the portion will be closed here. So this is the case in case of the open slot. Okay, but in this case, in case of the semi-closed slots, some of the machine secondary winding will be some of the closed here. Okay, only some air gap will be is there here. Okay, you can observe here. And here the advantage is coming to semi-closed slots. We have the some advantage will be there, that is because of this narrow air gap or narrow opening of the slots, the flux distribution will be uniform in case of the semi-closed slots. Okay, so because of narrow opening slot here, this is the narrow opening slot. Due to this narrow opening slot, the first flux distribution is uniform, and the average length of the air gap is less compared to this open type slots in case of the semi-closed slots. And also less reluctance of the magnetic circuit and the less magnetizing current and the better power factor will be there in case of the compared to the open type of the slots in case of the semi-closed slots. And some disadvantage will be there in case of the semi-closed slots, that is access of slot is little bit difficult to compare the open type and offer high leakage reactance to the windings. So these are the disadvantages in case of the semi-closed slots. Means it is in case of the semi-closed slots, we can't insert the large number of, it is not possible to insert the large number of coils in case of the semi-closed slots. Okay, so due to that one, it is access of the slot is little bit difficult to compare to the open type and the offer of high leakage reactance to the windings. Next is closed slots. You can observe here, total will be closed here. There is no open here. So in case of the open slots, this is the open slot type. In the semi-closed type slot, this is the semi-closed. Some of the air gap will be there. But in case of the closed type, totally closed here. Okay. So means in case of the closed slots, the advantage is here. Average air gap length is minimum here. Because of the total will be closed here. And the minimum excitation current and the improved no load and running power factor. And the flux distribution is uniform and the no flux harmonics are produced in case of the closed slots. And the smooth operation is possible compared to the open type slots as well as the semi-closed slots. Okay, because of totally closed here, that's why smooth operation is possible in case of the closed slots. Okay, and the disadvantage is access of winding procedure is very difficult and the leakage reactance is very high in case of the closed slots. Okay, so these are the stator slots. What are three types? That is the open type and open type slots and the semi-closed type slots and the closed slots. Okay, so you can observe that some parameters how it will be variation will be there in case of the open type slots and the semi-closed slots and the closed slots. Okay, what are the parameters I am taking here? I am taking the parameters are magnetizing current I am taking, no load power factor I am taking, input power factor, leakage reactance and the maximum torque and the starting torque and the harmonic torque. These are the parameters I am taking. Then I am comparing these parameters in the open type slots and the semi-closed slots and the closed slots. Okay, so means in case of the magnetizing current is greater than the, in case of the open slots, magnetizing current is greater than the semi-closed slots is greater than the closed slots. And the no load power factor is in case of the open slots cos pi naught is less than the semi-closed slots and the less than the closed slots. And in case of the input power factor, that is cos pi 1 is less than the cos pi 1 in case of the semi-closed slots and is less than the cos pi 1 for the closed slots. And in case of the leakage reactance, that is the XL is less than, in case of the open slots is less than to the semi-closed slots is less than to the closed slots. And the maximum torque, that is T maximum is greater than, in case of the semi-closed slots is greater than the closed slots. And in case of the starting torque, the TS is, in case of the open slots is greater than the semi-closed slots and is greater than the closed slots. And the harmonic torque is greater than the, in case of the open slots, that is TH is greater than the semi-closed slots and is greater than the closed slots. These are the parameters are varying in case of the open slots and the semi-closed slots and the closed slots. Depends on these parameters only, the working principle of the induction machine will be there.
Like, share and subscribe. Hit the bell icon for more updates.